I hope you all are up for some fun today. I have picked up new nuts for the top of the IF can. I bought brass ones because I thought they might look cool. Well, they do look cool, so I'm going to leave them there. I've already removed the old rusty nuts, as you can see, from the second IF can. I'm going to go ahead and take that one off and take a look inside there. And guess what? We're going to take the tops off of all three of these cans. The purpose of these videos that I put up is not to show you, my vintage radio restoration prowess. It's to educate you. Some people just like to be entertained by watching what I'm doing or what other restorers do who put up videos. But I want you to be able to learn. When I first started out restoring vintage radios, I told I told some folks I was going to take the IF can top off. My God, they had a heart attack. Oh, don't do that, man! Leave that alone. Why? Why should I leave that alone? This is an instructional radio chassis, and I'm going to show you that they were wrong about me taking off the IF can cover off that first radio I restored. Had I listened to them, today I would not be doing this. I would not understand what was underneath them. I would not know what's underneath them, and I would not know how they worked. Don't let these radios intimidate you. You just got to go slow. Be careful. Take your time, and everything will work out fine. Trust me. You can do these things. You just got to have the confidence, and I'm here to help you build that confidence, or at least I'm trying to help you build it. This particular kind of can, I should have showed it to you with this one over here, but this can here has squeezable clips that go down into the hole that hold it on. You'll run into other kinds of cans that have threaded studs that go down and there's a nut on the bottom. But this kind is kind of easy. All you have to do is take a pair of good needle nose, and be careful not to scratch or dig the can. Get right up close to it though, and then squeeze it. Make sure it's seated well. Squeeze it, and then lift. And as you can see, it's right out of the hole. There's three of those. I'll do it here. The one in the back will be a little more difficult, but you keep working around till you get it. Well, there she is. Got the lid off of that one, and again, it's pretty nasty on the inside, but other than that, it looks fairly decent shape. Now what I'm going to do is clean this up a little bit. I should have showed you last time how I cleaned it up, but it's just air in a can. The wife bought me this the other day. I wanted a can of air, and she brought back a extra duster, industrial strength, so now I have to be careful. It comes out, it's got a much larger hole in the hose, much larger hole in the hose there, so I'm going to just sort of blow this thing off around the wires. You got to be kind of delicate. Easy does it on the air. You don't want to go crazy. Here's another little tip. Sometimes when you're messing around underneath the bottom of the chassis, taking voltage readings or resistance readings, you kind of get lost. You figure out, what was that tube? Now sometimes chassis have a lot of tubes, and trying to remember them all and where they're positioned and going through the paperwork back and forth, it's a pain in the butt. You're sitting there with your probe and you're trying to find that tube. Which one is it? I found it's easier in the beginning when you first get your chassis torn apart and you're examining it and getting to know where the wires go, what resistor goes where, and all that sort of thing. It's easier to just take a marker pen and just mark next to the tube socket on the bottom of the chassis what the tube number is. In this case, it's a 78. Well, that's it for the second IF can. All back together, nice and secure. Put my brass nuts on the top, and I had shined it up with the brasso. We're beginning to show a little progress on this thing. It's coming along nicely. Yeah, let's take off one of these larger ones now. See what we find. These three cans are the RF antenna and oscillator coils. They have adjustments down in the holes. Now on the schematic that I showed you earlier in the video we had, we're talking about this set of coils, this set of coils, and this set of coils. Now the bottom one is the antenna, and as you can see it says antenna, and it leads right down into that band switch, and then from there straight into the coils. The center one is the oscillator coil, and the top one is the RF coils. According to the parts placement diagram that I have, that I got from Chuck Schwark, the can in the front is the antenna, and the one behind it is the oscillator, and the one further back is the RF. So we've got antenna, oscillator, RF. And you know, it comes out of the chassis with the same type of clip as the IF cans did. Just squeeze that baby together. You can see how it squeezes together like that, and it'll just come right up. Now they're a little difficult to get to. Sometimes you have to go from underneath and get the needle nose up from underneath it and squeeze it together until you can get it up out of the hole. Slowly work at it. Take your time. There's no rush. You'll hear me say a million times, there's no rush to repairing these old radios. They've been sitting around for how many years? Another month won't make any difference. These cans here, down here you'll see a little slot. There's one on each side, and there is a little protrusion on the bottom of the disc at the bottom of the coils that sticks through the lid. I mean, sticks through the slot in the lid. I had to kind of take a pair of long needle nose pliers and just kind of get up under there just enough to move it out just a bit to where it would drop down a little bit. And then I took this little sucker here and kind of went like that, and it popped it right out. And when I do that, of course, the one on the other side just automatically falls out. And voila! Now we all know what it looks like inside one of these cans. You'll see that the coils are much more heavy duty. Much more heavy duty. And you've got a set right here. These are actually very thin wires, but there's a lot of them there, and they're heavy duty. Another one here, and of course a third one down here. So what we're going to do now, there's quite a bit of dirt in these things. Look at all that crud. I think what I'm going to do is take it outside and blow that thing out. It's time to ohm out the coils. I'm going to ohm out this first one, and I'll be doing the exact same procedure for the next two. I've stuck my negative multimeter probe inside that rivet right there, which gives me a connection to this plate. And I've got my multimeter set up on R times 1. I decided to use an analog meter so you can watch the needle jump or not jump, depending on the continuity I get. Now I'm going to be touching the positive probe to each one of these screw tops. This is a capacitor, and it's separated from the plate with mica. And I'll go from one side of the capacitor through the coil and back to the other side of the capacitor. One side of the capacitor is connected to the plate, the other one's connected to that screw. So I've already got my plate connection. So let's see what we get when we go. Now keep your eye on the ball, as they say. Okay, you watch this needle down here. Now hopefully it'll work. Okay, there's one coil. Touch the screw to the other one. There's two coils. And we'll go back here and touch it to the third coil. Keep your eye in the needle. And there's the third coil. Okay, the three primary coils in this antenna coil setup are good. Now we need to check the secondaries. Same basic setup is established to check the secondary on these coils. Each one of these coils also, not in addition to the primary, has a secondary. They're actually little transformers. We've already checked the primary. Now we'll check the secondary. I connected the negative probe to this can just to give me a negative point because the secondary coils are all connected to ground. The ground being the chassis. So that'll be my chassis connection right there. And just make sure we do have good ground. Let's give a check here. And yes, we do. The needle is moving up. Okay. What we're going to do for the secondary coil checks is we're going to touch them. We're going to take the positive probe and touch them to these rivets down here. These rivets connect the secondary and the primaries down to the band switch. So rather than go up underneath and try to figure out what band switch goes where and what connection goes to which pin, we'll just do it from the top. That's the sweet thing about removing the top of the can. You get to do it a whole lot easier. So let's take this one first. I'm going to touch this. Watch that needle. Yeah, we got a good secondary there. Okay. Now we'll come over here. We'll skip around to maybe this one here and see what we get. Nothing there. Nothing there. Let's go to the next one. There's the next coil. The secondary is good. These things on the schematic might show, say, 60 ohms. This large one right here might show a reading of 60 ohms. But over the years, that's going to change. It's going to go up, it's going to go down. These are very old, and the coil forms that they were around have warped and twisted and changed, and you're going to get different readings. So at this point, all we care about is continuity. And we do have it, primary and secondary. I'll do the same thing for the remaining 2 cans. Wish us luck. Here's a little something that's interesting on this oscillator, on these oscillator coils. All of these are down fairly tight. You know, the screws have been down. There's one that's lifted up very slightly. These are all down nice and snug. They're the adjustment capacitors for each of these coils, the trimmer caps with a piece of mica between. But look over here. This is the police band oscillator trimmer cap. Look how far up that thing is. I could slide a screwdriver completely up underneath there. Somebody has been trying to adjust it and it hasn't been working. And I think I know why. I think the secondary on the police band might be no good. I just opened it out and I cannot get the resistance that I need. So, but you never know with these old radios, you know. I've had variable resistors that did not work when I ohmed them out. Did not work at all. But when I put them back in the circuit and finally got the radio to where it was all back together, they worked fine. Strangest thing. So what we're going to do, I've cleaned it all up, and I'm going to leave that just like it is and kind of keep a mental note. That is the police band oscillator trimmer cap. If the police band is not working, I'll know why. Alright, the old antenna can, coil can, the oscillator can, and the RF can have all been put back in place after being shined up with the old brasso. I also picked up some brass screws at the hardware store to make it look a little better. This radio is going to be mine. This is going to be sitting on my bench, and I like brass screws holding the cans on. I just think it looks neat. And I like them shiny. I like them clean. I like it looking really spiffy. So now I think we'll work on the chassis itself a little bit. Maybe clean up some of this crap on here. Some of it will come off, some of it won't. But we'll see what we can do. I hope you're beginning to see what a little time, patience, and energy and a little elbow grease can do, even to a nasty looking radio.